everyone, and thank you for the introduction. I'm sure that if you're in the audience and managing a website, I'm sure that you're very familiar with the topics that we're going to talk about today, which is bots. Over the years, their numbers and complexity has increased significantly, meaning that us defenders had to go in all lengths to improve our detection in order to be able to keep up and stay ahead as much as possible, in order to be able to detect them and defend the site against them. My name is David Senecal. I'm the VP of Product Architecture and Research at Arcos Labs, and I've been spending the last 10 years of my professional careers chasing bots around the internet. And with me, I've got a pleasure to have Luke Stork.
Hi, thanks, David. Yeah, I'm Luke Stork. I've been working in data science and machine learning for about the last 5 or 6 years. Started at the Air Force Research Lab doing human-computer interface research, then moved on to a biometric startup. And about the last year, I've been working with David on trying to improve a product for detecting bot and human fraud.
Right. So today, let's talk about the agenda. So first, I talked briefly about introducing the topic of bots. Let's talk first about the type of attacks that we are seeing. And second, I think it would be good to kind of talk about as well what drives the attack sophistication. Why do we see the persistence in those attacks over and over again? And like I said earlier, I've been doing this for the last 10 years, and over time, I've seen the attack evolve pretty significantly. And I want to give you an insight about what I've seen over the last 10 years, where we were 10 years ago and where we are now. As a follow-up, then we'll double click in some of the most complex and advanced method that we're using today, which is behavioral detection. So without further ado, let's look into the type of attacks. So when we talk about attacks, you sometimes hear about account takeover, fake account creations, carding, denial of inventory scraping. But what do they really mean? So for example, account takeover. Typically, those account takeover really take place on the login endpoint, where attackers are typically buying credentials that were stolen on the internet and then posted on the dark web. And there's a lot of marketplace available out there where you can actually buy stolen credential. And what attackers do is that they buy those credentials and keep replaying them over and over again against multiple targets, taking advantage of the fact that a lot of the internet users actually end up reusing the same username and password across a lot of websites, meaning that if a credential is valid on one given website where the credential were stolen, chances are it's also valid on other websites. And then once they verify that a credential is valid, then they can take over the account or actually resell those verified accounts to somebody else to take it to the next level and take over the account. So Luke, what do you know about fake account creation?
Yeah, fake account creation is another really common type of attack, and it's common on many different types of platforms, from e-commerce to travel websites to what we hear in the news, like social media accounts with fake accounts that spread misinformation and spam. So yeah, it's a really common type of abuse, and it can happen in a number of different forms. You could have a human actor that's coming in there and just putting in fake information and creating these accounts one by one, or you could have an automated system that goes in and really rapidly creates a high volume of accounts. But it's a particularly bad type of attack because it can only take 1 or 2 accounts, say on like a gaming platform. You have 1 or 2 fake accounts that get created, and these accounts can really be, they can spam other users and really degrade the user experience for everyone on the site. So it's a really bad type of attack that can happen. So
yeah, and one additional point is, like, once the fake account is created, they can potentially be used to, to do a different type of attack, which, for example, carding. Yeah. So they would reuse the fake account to actually test credit card numbers to see if they're valid or not, and then valid and make purchase from them. Or also try to do the similar things with gift cards. So that's pretty much like the second layer of that attack is typically carding. So Luke, what do you know about inventory scraping?
Yeah, it's another type of attack, and it might not even be necessarily an attack. There's a lot of benign automation on the internet, and actually most web traffic is this type of benign automation that just has these web scrapers that go around the web that aggregate information that figure out the best price for goods and services. So these types of automation aren't necessarily bad, and they help the internet function. But what makes it bad is when this automation goes to try to find information that we don't want it to see. It tries to scrape personal information from social media profiles, or tries to dig in further to get information that we don't want it to see. So that's where it really becomes an attack, and we want to be able to detect and stop those cases.
Yeah, so for example, like web search engine obviously is good traffic that we want to see. Website owners do want web search engine to actually go through their site so that their content can be indexed and made available to users. But obviously when that scraping is done by competitors who's trying to take an advantage on the pricing and so on, that's definitely bad things. And sometimes it can lead to some very serious issues for the website owner. Take the travel industry, for example. If too much of the scraping is done, and depending on the workflow within the website, it can sometimes lead to actually denial of inventory, because the scraper is potentially trying to check the availability of, say, a seat on a plane or room in a hotel. While they do this, sometimes you have process where the actual room or the seat is kind of locked for a little while, and then that can lock the whole inventory for all legitimate other users who may actually want to purchase those available seats or room. So it can definitely lead to some serious, has some serious financial consequences for the actual website owner.
Mm-hmm, mm-hmm. Yeah. So you outlined all these types of attacks, but so Dave, you've been working in this for a while. Like what drives like this attack sophistication? Why do they get really, really sophisticated?
Yeah, so what I've learned typically is really what drives the sophistication of the attack is it's pretty much the potential for monetization of the content that's being abused. So the lower, if the potential for monetization is low, then potentially you'll see sophistication of the attacks that's pretty low as well, and the persistence is pretty low. So you're gonna find like more basic botnets who do their things, and as soon as you got a decent defense in place, then they will go away and they will try to go after a different target. However, if the potential for monetization is very high, let's say by spending 1 hour and trying to get the content, and they can have a resale value for $100, let's say, or even more, then the value for them is so much that it's actually they can make a good living out of this. So in that case, they will try very hard to actually defeat all detection in place, and that's where you're going to see the most sophisticated attacks. With very high persistence. I've seen over the years some accounts that I've been working with where pretty much they're one of a kind, where the value from abusing logins or cracking an account or abusing some gift card or loyalty points program, it's so lucrative that the attackers will keep going at it no matter how much defense that you have in place.
Mm-hmm, mm-hmm. Yeah. So what kind of, you have these really sophisticated attacks that happen. So I'm sure there's kind of a spectrum of attacks that we see. So like what's a good starting point, like a really basic form, I guess?
Yeah, I mean, you cannot bring him back. It brings me back to like 10 years ago, where I started trying to play around defending against botnets. And at the time, things were much easier because the botnets were pretty small, fairly unsophisticated. We were looking at like fairly basic scripts. The number of nodes within the botnets was fairly limited. You're talking about like maybe a few dozens of botnets or nodes within the botnets. So in that case, defending was pretty easy, where pretty much IP blocking would do it. That wasn't that hard to actually do the inventory of IPs that would attacking you, because it's easy to find them, because you would see like a very large number of requests coming from very specific set of IPs, where the rest, is pretty much in the much lower range. So IP blocking would do the trick. Rate limiting as well would do the trick. And because the script was so simplistic, then a set of custom rules would do the trick as well, because the format of the request would potentially very different than the format of legitimate request coming from a regular Chrome or Firefox. So then it's easy enough to detect.
Mm-hmm. Mm-hmm. Makes sense. So okay, so you got these, I guess, dumb bots, but what's like the next stage from there? How do they get more sophisticated?
Yeah, so basically the level of sophistication increase as your level of detection increase. So then the next stage, when you've got all this very basic detection in place, typically what you'll see is that the botnet will evolve. They become larger to evade your IP blocking. It's harder for you to do the inventory. And then because the botnet is larger, we're talking about maybe a few hundreds nodes within the botnet, then in that case, rate limiting becomes less effective, because each node within the botnet is able to only make a few requests per minute or per seconds. And, it blends in with the rest of the crowd. So to defend against this, then, that's where IP intelligence comes in, because where IP blocking and rate limiting will fail, if you look at the traffic from a longer period of time, if you look at the reputation of an IP over a longer period of time, so what you get typically from IP intelligence, then in that case, you will be able to kind of differentiate between potentially detect the nodes within the botnets. But that's not enough, because another thing that you need to do is typically those basic bots, they don't run JavaScript. So what you can do is actually inject some JavaScript challenge into your code to be able to validate whether they do run JavaScript or not. And if they do, then you want to collect the fingerprints from them to kind of look at the device characteristic and these sort of things to kind of see what kind of system you're dealing with.
Mm-hmm, mm-hmm. Okay, so we got 100 node botnet that can run JavaScript. What's the next level of sophistication from there?
Right. So yeah, of course, my job is never over, and our job is never over, right? So once now you're happy, you've kind of dealt with your larger botnet, you feel like you've done it all, and you've taken care of the problem. Fortunately, that's not the case, because if the incentive is there, then the attackers will go above and beyond to try to defeat your detection. So the next stage is actually the botnet goes even larger. We were talking about a few hundred nodes, and now we're talking about a few thousand nodes. And it's actually not uncommon to actually see botnets that are, have more than 10,000 nodes within the network. So that's, then in that case, IP intelligence becomes, it's not very efficient. So, and as well, when we test for whether the client supports JavaScript, one of our basic way to know whether the client supports JavaScript or not is if we see that they're sending a fingerprint, then that's like, okay, now you're good. You're giving us your fingerprint, therefore you must be running JavaScript. But it's easy enough for an attacker to actually simulate sending a fingerprint. They know that that's what we expect. So therefore, they're going to just give us a fingerprint. And sometimes what they do is like they randomize certain values within the device characteristics that we want to collect. Actually, it's very common. And so that to kind of defeat any detection in place that would pinpoint on very specific characteristic, like particular version of browser, OS, or certain characteristics. So then in that case, in terms of detection, you have to advance a lot more, like a simple rule engine for looking at specific characteristics or anomalies won't do it. You need something a bit more advanced with like device intelligence, for example, who can recognize legitimate system versus non-legitimate system, meaning legitimate fingerprint versus non-legitimate fingerprints. Proof of work as well is a good way to force the client to actually run the JavaScript, because proof of work is based on the JavaScript ability to kind of resolve a cryptographic challenge. And the cryptographic challenge will be unique every time, so it cannot be pre-computed. So in that case, it's a good way to really force the client to run JavaScript. And of course, you need to also be sure you have some replay detection in place, because some attackers will be clever enough to kind of replay a good fingerprint, and you need to be able to recognize that as well.
Mm-hmm. Okay, so we have really, really large botnets now that can run JavaScript and spoof legitimate device signatures, but like, how does it get any more sophisticated from there?
It always gets the more sophisticated, and once you really push them to run JavaScript, then they go headless browsers, because headless browsers, of course, they can run JavaScript all day long. So then your proof of work becomes ineffective. Device intel also becomes somewhat ineffective, because in that case, the signature of that headless browser send is valid. Like headless Chrome is the same as Chrome in terms of fingerprint, or there's very little difference sometimes you can make out. So then you really need to kind of step up your headless browser detection, and then you also need to look at how the user is interacting with the system, with the machine that you're receiving the request from, and how it's interacting with the website overall. So that's where we start talking about behavioral detection, which is the bulk of our topic today, and that's why you come in, Luke. So Luke, sorry, tell us about behavioral detection. What does it mean? What is it like?
Yeah. There's a couple of different sides of that. For behavioral detection, there's behavioral biometrics, which is we'll touch on a bit later, and then kind of a broader, more simplistic arm of behavioral detection, which is user behavioral analysis. And this is kind of just a high-level method that looks at a way a user interacts with a web service. And this can be, just the series of steps they take when they're, logging into an account or making a purchase. Just those high-level contextual interactions is kind of what comprises user behavioral analysis. And it also can take into consideration, their geolocation and the timing of their visits and the frequency of page interaction. So those really high level metrics.
Okay, and so what about behavioral biometrics then? What does it mean really? What are we looking at?
Yeah. So behavioral biometric detection is different from behavioral analysis, because we're looking at like the actual ways that a user interacts with their device. So for like a traditional desktop session, we're looking at these mouse and keyboard events, the actual frequency of these typing events, the speed of their mouse motion, and those sort of things. And then for the mobile side of things, we're looking at the touch interactions on their phone, and even more complex systems can look at motion sensor events and that sort of thing.
Right. So we're gonna double click on each one of this detection method to really give some insight to our audience about what that means and what it really takes to kind of handle this sort of signals. But before we do that, let's go over kind of discuss the use case we're trying to resolve with behavioral detection. So again, botnet detection is definitely one good use case to be really be able to differentiate by seeing how the client is interacting with the site or the machine. Then we can differentiate between automation and human. But also by looking at how the interaction is happening, we can potentially also start differentiating between legitimate users and people who want to start committing fraud. So you cannot get maybe a bit of a sense of the intent as well. But not only that, that's also a good way to evaluate for legitimate users that has no bad behaviors and they're just doing the stuff that we expect the regular users to do, then to be able to better identify them so that we can give them a better user experience when they're returning to the site. So let's dig deeper into the user behavior analysis. So, Luke, tell us more.
Yeah. So a deeper dive into this aspect of behavioral detection, and again, we're looking at these high level contextual interactions. And kind of here on the right, we have like a heat map of mouse motion. So a lot of these metrics kind of overlap with techniques that marketers use to examine, interactions with ads, or user experience researchers that want to know how effectively a user can navigate through a website. So a lot of those same metrics can be used on the security side of things to verify like the authenticity of a user session. So kind of more granularity into those metrics. We're going to be looking at like the number of pages that they visited, maybe the sequence of events that led them up to this session, and that can be really telling for kind of a contextual point of view. If you're seeing a lot of sessions that just begin their browsing session with this page over and over again, that might be a red flag for detection. And again, like on that same note, the visit frequency to a page, are they trying to visit a login page 10 times a day, 20 times a day? That could be a red flag as well. And again, the time spent per visit and per page is a key metric, because like David outlined earlier, we have these really complex automated systems, and they're financially motivated. So they want to be really efficient with how they navigate these web pages. So they're going to do these actions as quick as they can to really improve their margins on the fraud they're trying to commit. So the time spent per page is really key, because normal user browsing, you're going to scroll down a page, you're going to pause, you're going to hover, you're going to read. You just don't see that type of behavior for really large automated systems.
Yeah, and the one point that you're making, like on the how the user is browsing the website, how is they accessing a particular resource, I've seen that many times in the past, where especially on the case of account takeover or credential stuffing attack, where they're replaying a large list of username and password. All too often, what you're seeing is just they're simply making a post request with a login. They're not even going in any user web page before, not the home page, not browsing any product if it's a commerce site, not even loading the login form itself. Directly, all you see is a post request. So that's definitely can be a good way to tell where we're dealing with legitimate activity or not.
Yeah, it just misses that context going up to that event.
Yeah. So now let's talk a bit more about behavioral biometrics. So let's talk about the sort of data points that we want to collect in that case from depending on the type of client, because imaging between desktop, laptop, mobile devices, and even in our case at Arcos, we're actually dealing with like even game console and smart TVs. So then the interaction with those type of devices completely different. So what does it look like from a point of view of desktop and laptop, more traditional devices?
Yeah. So that's exactly that's where behavioral biometrics traditionally originated, was kind of this desktop session of these mouse and keyboard events. We're looking at the frequency of keystrokes and the speed of the mouse motion. That's the traditional form of behavioral biometrics. Yeah, and then we go on to the kind of the mobile world, where we don't have those mouse events or those key events necessarily. So we're going to have to look at touch interactions on the device and those motion sensor events to give context to that user session. Yeah,
that can be a bit tricky with mobile, because you can actually hook up as well a keyboard or mouse to a mobile device, where sometimes would not, and that's kind of a bit of a blur sometimes. And you do also have some laptops now that actually do support touch on the screen. So
yeah, that's a great point. It's not really you can't cleanly separate devices into mobile and desktop necessarily anymore. It's kind of a hybrid. You have touchscreen interactions, and it can be difficult to differentiate. Yeah,
for sure. So what about those smart TVs, game console? What do we get out of those? Like when I'm interacting with my remote on my smart TV to try to log in on Netflix, for example, what kind of interaction can you get out of that?
Yeah. And again, this is a whole nother world for data collection here. For like game controllers, a lot of those events get translated down into key press events and that sort of thing. So we can interpret that information that way. But there's a whole other world that's coming with these IoT devices. I mean, you have your thermostats and doorbells and your refrigerator interactions. So it's a whole world of different interactions that we're dealing with. Yeah.
Yeah, no, the fun never ends for us.
Right.
All right, cool. So right. So I mean, obviously, rich amount of data, tons of data here. But how do we sample? What's the right sampling of that sort of data?
Yeah, and this is a really important point. To have a successful behavioral biometric implementation, it's all about how you sample the data, because these types of events have a huge volume of data. You simply can't ingest it all. Like, you would ruin the client experience, you would overload your database, and you wouldn't even be able to get the information you want. So you have to really be smart about how you sample it. And in the first and kind of simplest way to do that is in an unconstrained way across, say a web page. You're going to sample this information at maybe, a 1 to 2 second interval per event. And you would just collect, whatever mouse events happen in that window, whatever key press events happen in that window. And you would just make sure that they're consistent with what the client should be sending you. And another form of this, the other side of the coin, I guess, is constrained sampling. And this is when you have a specific window that you're looking to collect these events in. And this is, say during password entry, or like in our case, during a CAPTCHA session. So you have the specified window, and you're going to collect all these events, and you're going to make sure that they're consistent and they have the information that you want. And again, you just can't collect all the data, so you really have to narrow down that window that you're focusing on.
Well, typically, what's the sample size you're looking at? How many events are good enough to have like a good sample to work with?
Yeah, there's definitely a spectrum. I mean, for simple bot detection, a case would be just make sure the client sends you mouse events. Just make sure that those events are there. That's the simplest case. And then like we'll touch on a little bit later, like if you want really sophisticated bot detection, you're going to have to collect more data. You're going to have to look at, the time series of that data to make sure that it actually looks like it's human. So basically, like your earlier point, the more sophisticated you want your detection to be, the more data you're going to have to collect.
Okay, so let's look now at how we use that data, right? So now let's say we are looking at our mouse data, right? So what can we do with that?
Yeah. So the simplest form of looking at mouse motion data is just the timing, just looking at the trajectory of a mouse or touchpad interaction. And here on the left, we have, a simple human interaction. This is the mouse X coordinate on the Y-axis versus time on the right. So this is just someone clicking at the top of a page and moving their mouse to the right a little bit. And you can kind of see on this trajectory here, it's not really even. You kind of get lumps of those coordinates. It's kind of you get those kind of curvy things at the end. It's a little bit chaotic and not the cleanest necessarily. And then here on the right, we have a machine profile on the same web page that was just this would be the really dumb bot that David outlined earlier. That's just explicitly programmed to click certain events, and you can see it's just really clean. The events happen at a specified interval. You don't have that really rich time series trajectory.
Okay. So time motion is one thing. So what else can we use?
Yeah. And again, as we move up this sophistication line here to detect more sophisticated bots, we can look at the velocity of the mouse motion. So on the left here with the human motion, that same motion that we were looking at on the last slide, the velocity profile of this, you can kind of see these peaks and valleys. It moves quickly and slowly. It's not really clean, not linear. And that's typical human web interactions. They're chaotic and messy. There's really no rhyme or reason for events. Sometimes it's kind of jagged and peaks and valleys. Yeah.
Right.
And then on the right for the machine interaction, you're going to get really linear events for these simplistic interactions, and it'll be a consistent velocity from one point to another. and you're not going to see that sort of the rich profile that you do on the left.
All right, cool. It's fascinating. So what about acceleration?
Yep, taking it another degree further. So say you have a sophisticated bot that can, move at a non-constant velocity. We can examine the acceleration profile of the mouse motion. So again, this is that same time series trajectory that we're looking at from the first slide. And the acceleration profiles, it's really telling. So with this human motion, you see that kind of jitter there. It's uneven, lots of peaks and valleys, and that's what we want to see for a normal human interaction with a touchpad or mouse. And then on the machine on the right, again, even the acceleration profile, you have those really linear types of trajectories, and you don't kind of get those jagged peaks and valleys.
Yeah, I like, can definitely see some kind of pulse on the left, whereas on the right, there's definitely no pulse. The guy is on life support right there.
Yeah, there's signs of life on the left for sure.
All right. Now, so on mouse movement, obviously, we get a ton of those when it comes to laptop and desktop devices. But now let's look at the mobile world. So touch events, what do you get out of that? Is that as rich as what we would get from mouse event?
Yeah. So it depends. Typically with touch interactions, you don't have the full trajectory of like a mouse motion event. So with the touch interaction, you don't get to see where that interaction began and where it ended. Because you have those single points on a screen. So like with the human here on the left, we don't have that trajectory, but you can kind of see there's a couple points clustered together there. They're kind of smudges. They're uneven. The time won't be constant in between these touch interaction events. So that's what we're kind of looking for human touch events. And then on the right with a machine touch profile, what we'd be looking for just missing events altogether. If you say you're a mobile device with a touch screen and you're sending only these events as mouse events, that will be a rule that we're looking for detection. And then again, looking for only those single data point coordinates instead of kind of the smudge interactions.
Right. Yeah, I mean, obviously the touch event is probably easier for bots to kind of fake in that scenario because you have far less to work with, and then your algorithm won't be as accurate. So go ahead.
There's even research that's trying to tie motion sensor events like accelerometer and gyroscope to these touchscreen interactions to make sure they're legitimate as well. So there's another dimension that could be even taken further. Yeah.
Right. So yeah, that's a topic we won't touch too much today, but yeah, definitely in the case of mobile, then potentially you have the opportunity to have much richer signals that you can work with to kind of see how the user actually interact, handle this device, and then to compensate for this lack of interaction on the touch on the screen event, right? Yeah. Okay, cool. Now let's talk about keyboard. We all have keyboard. We're all day in, day out, during time of pandemics, typing away at our keyboard. So there's probably some rich interaction we can get out of that. So what do we collect exactly? Do you really collect when I'm typing, or do you collect something else?
No, and that's a good point, David. And we should have highlighted this early. This is, we don't want to collect what a user is typing. We want to collect the dynamics of the events, but we don't want the content, and that's a liability to even have the content for your website. Like, you just don't want to collect that information, and it doesn't help with your purpose for detection either. So what we collect with key press is the timing of the keystroke. So how long a key is held down, and then the difference between that key press event and the next one. So that downtime in between the next key and the other one. And this is really rich. Just the temporal interactions that a user has on their keyboard is really telling. So you can use that for both bot detection, whereas a bot, you might not even have those key press events at all. That information might just automatically be entered into forms for like human fraud detection. It might be very quick. You might see a lot of copy paste events. And then we touched on earlier for same user authentication, someone's typing pattern can potentially be uniquely identifying. So that's another point.
Yeah, well, I feel much better than now you're not snooping on all everything that I'm tapping over email.
Yeah.
But, yeah, I mean, it's definitely a point that we need to make sure that we're making. All of this detection, of course, has to follow, regulation like GDPR and CCPA in California, and we can't collect whatever we want, but we need to collect enough so that we are able to be able to build detection around it.
Mm-hmm.
Now, okay, so I mean, the biggest problem that we have in the industry in terms of, when we launch a new detection is always, at the end of the day, the most common way for attackers is to do spoofing. So spoofing of spoofing of device characteristic and the data we're collecting through fingerprinting with JavaScript. It's very common. I've seen that for many years. Do we see the same problem with behavioral biometrics, and how do we handle this?
Yeah, and of course, for any detection system, the data is going to be spoofed for it. It's just known. It's just a cat and mouse game. No matter what, if you're looking for device characteristics, the attacker is going to spoof those. It's just how it happens. So yeah, of course, behavioral biometric data gets spoofed very often, and there's a lot of different ways to spoof it as well. Probably the most common and easiest way to do this is to just record the normal user interaction. So an attacker might just, collect their mouse events as they go to create an account and play those back into their automation system. So that's a really common and probably the easiest way to do it. But we can detect those events by looking for these type of replay events. So just looking for that exact same input that was sent before, you can detect that very easily. And then the next stage of that would be kind of the attacker might modify that signal, just put a little bit of noise in there for that same replay session. And again, with some filtration and kind of statistical techniques, that sort of replay attack can be detected as well. And then there's, on the most sophisticated side of things, there's behavioral biometric systems, machine learning systems that can generate mouse coordinates, and they can generate realistic keystroke realistic keystroke events. So it can get really sophisticated, but again, there has to be that monetization incentive to do that, to spend the time to implement one of those systems.
Yeah, and I guess that's, then that means that we're going to have to come up with something new after behavioral biometric and behavioral detection. We have to come up with something new to be able to go beyond, the fact that over time they're going to get better. The attacker are going to get better at detecting all this. The replaying and simulating all this behavior that we're doing. It definitely increase the cost for the attacker. So then it's, but again, it's based on the motivation. The higher motivation, the most likely they're going to be able to go that way. But at least we are raising the bar, and that's also still good overall. Yeah,
that's a great point. Just that monetization potential is really what drives the sophistication. Yeah.
So let's talk a little bit about the pros of the cons of behavioral detection, because it sounds very complicated, it sounds very promising, but it sounds very complex. So tell us about the pros of behavioral detection.
Yeah. We'll start with the pros for this, and really the main benefit of behavioral biometrics is that they're passive, that they happen naturally in the background. It's not a CAPTCHA that you're imposing on the user. It's not additional friction when a user goes to make a purchase. It really doesn't reduce the user experience at all. So that's really the main pro of them. There's no friction. So in addition to that kind of passive detection mode, another benefit is that they're really unique and independent from other forms of traditional detection that David talked about earlier. It's an independent signal from like your IP information. It's an independent signal from whatever device that you're using. and it can really act as a differentiator for detection systems. And then another pro for behavioral detection implementations is they're really hard to spoof in an intelligent way. You can do those simplistic replay attacks, but if you really have a good behavioral biometric system, the bar is pretty high for attackers to really spoof that stuff in a complex way, and they really have to be motivated, and it has to be a system with that monetization potential for them to really use those smart methods.
Yeah, definitely. Yeah. So now let's let's talk about the inconvenience of behavioral biometric. Behavioral detection overall.
Right, and it's not a perfect world. So on the other side of the coin, there's many cons to behavioral biometric implementation. The main one is it's really complex. There's a lot of development that needs to go in up front. These systems really need to be maintained. Like the way you sample the data needs to be implemented in a smart way to begin with. It needs to be maintained across, dozens, hundreds, however many devices that you're going to see across this. And then you have to be able to store that data in an intelligent way. And it's very, very complicated. And then once you have all that data in your database, you're going to have to be able to perform computation on it. You're going to be able to filter it to be able to find the events that you want. So it's really data intensive, computationally intensive. And then also on the last point, like we touched on a bit earlier, there's privacy concerns. So initially, when you're sampling this data, you don't want to collect any PII information. You don't want to collect these explicit key events, and you really have to be smart about what data you're collecting. So with all the benefits it brings, there's a lot of maintenance and cons on the other side of the coin.
Yeah, well, it sounds like you're going to be very busy for the next few months or even years, Luke.
Yeah, definitely.
So one aspect that you brought up earlier on is like what we talked about briefly is like, in a way, it's frictionless system, and potentially it can help for user authentication. So tell us about how behavioral detection at the end help with user authentication.
Yeah, good point. And this is a bit separate from bot detection and human fraud detection. Right. This is a bit of a separate avenue in itself, but it can also help to streamline the user experience and help them not see CAPTCHAs and really make the web experience a bit better. So the way kind of behavioral profiling works for when a user has an account with a web service, they'll interact with that account for the first time. Say they're registering for an account and maybe they log in for the first time. We're going to check to see if this user exists in the database at all. Do they have a profile? Have we collected data on them before? And if that's not the case, we're going to go on the right side of this flow chart here, and we're going to collect data from that session and either store that in a local or remote database, and then the user carries on with that transaction. So the next time they use this service or interact with the website, we're going to go through that same check, and we'll do this a number of times until that user has enough data collected on them, enough keystroke events, until we know what time of day they usually use the service, what geolocation that they typically come from, and then once we have enough of that rich data set, we can use some sort of basic statistics or thresholding to learn that profile. And then the next time that they use this service, we're going to run their information through that profile, and then either authenticate or reject them. Or what's more likely is there's kind of a confidence score for that user. So when that user goes into that web interaction, it would be a score from 0 to 100 that we're 75% sure that this is actually you interacting with this website. And then other methods like a CAPTCHA could come into play or whatever it may be. Right.
Yeah, I mean, what I like about the behavioral detection overall is like, it opens possibilities. It has several applications. So that's why we wanted to kind of share this kind of use case around authentication. But in general, of course, the bot and overall, it's good for bot and human fraud detection. One thing is important to remind as well is basically behavioral detection on its own. It's not typically it's a layer within a system that you're deploying. Typically, just having like behavioral detection on its own may not get enough context to be able to be successful. So typically, behavioral detection is deployed within a system that includes things like device intelligence that I mentioned earlier, as part of some of the bot detection techniques, where you can learn what's a good legitimate device, what their fingerprint look like in the internet ecosystem. And that's evolved very rapidly because, every so often you got the Google, Apple, and of the world to release new version of their product, and that in a sense may constantly evolve the internet ecosystem. So having a good device intelligence system as part of the detection is kind of a must. Then as for context as well, having network and IP intelligence to really know where the user is coming from, what kind of networks they're coming from, whether it's a data center or residential, or if it's a proxy, a VPN, or this sort of rich metadata that you can get from IP intelligence kind of help kind of bring the context that can then be used as part of user behavior analysis. So device intelligence, network IP intelligence is definitely a key point used as part of user behavior analysis to be able to understand, like based on what the user is doing and based on their device and based on where they're coming from, kind of make some sense about what they're doing and make a determination between whether they're human, bots, good human or bad humans, so potentially bad humans, right? And behavioral biometric as well comes in to kind of reinforce all these signals of device intelligence, device intel, IP intel, and user behavior analysis. But of course, all of this needs to be processed in a fairly complex way. So that's where machine learning comes in. That's where Luke comes in, and doing all the data science around it, or also sometimes some simple statistical model can actually do the trick and really help provide a good level of accuracy. So it's really a system, and here I've just highlighted a few of the methods that we're typically using. There's always a few additional, like rate control and velocity and this sort of things that comes into play. But overall, we want to kind of bring home that this is a complex system to put together. And yeah, so that's great. And so thank you, Luke, for participating in this conversation. I think we've learned a great deal from behavioral detection today. And with that, I think we have some time to take some questions.